So, hello everyone. Welcome to the first webinar of BAYKON Industrial Weighing Systems about the innovations and renovations in the weighing industry. My name is Uğur Doğan Sözer. I will be your host during this webinar. And I can definitely see some familiar faces from and outside the industry. It's really cool to see a wide variety of people attending our webinar. So before I start, I would want to ask again, is my voice clear? Sesi mi? Tamam. Okay. So now this webinar will be about electronic calibration, eCal for short. And what electronic calibration is very clear from its name, and me and also us personally think that it provides great convenience in the weighing industry, especially in the field. Therefore, we wanted to start this webinar series with this feature. Let me share my screen with you real quick. Can you see the screen? Geliyor. Tamamdır. Is it clear? All right, nice. So, as I said, today's webinar is going to be about electronic calibration, eCal for short. What electronic calibration is pretty clear from its name, and me personally, I think that it provides great convenience in the weighing industry, especially for applications that are field specific, and therefore we wanted to start the series with electronic calibration. So the table of contents. The topics that we'll be talking about are as follows. First, we will be talking about manual calibration. Then we will be briefly talking about steps to calibrate a weighing equipment. And then we will be talking about the problems that we face in the field on a daily basis on manual calibration. And the problems are going to be problems regarding the weight, logistics, essential labor, time, and resources to calibrate a weighing equipment manually in the field. And then we will start talking about electronic calibration, show you how it is performed in our devices. And finally, we will be talking about our devices that have this feature integrated. So, all right. Now, for me to explain what electronic calibration is, I think it is necessary to explain you what manual, also known as normal calibration is, because we need to understand why do we need the electronics version? What benefits does it provide? Answering these and such questions is important for us to understand in what way electronic calibration provides innovation, because obviously there were some difficulties in certain stages, so that we needed to come up with electronic calibration in the first place. So what is scale calibration? Calibration in the weighing industry, in its simplest definition, is ensuring whether a measuring equipment is testing accurately or not. As simple as that. We have a scale. You can see it on the slide. And as you can see, the scale that we have on the slide is weighing the test weight placed on it incorrectly. In other words, the scale needs to learn the amount of weight placed on it. And calibration is basically teaching the scale the amount of weight it has on its current state. And how do we do that? How do we teach a scale the amount of weight that is on it? How do we teach the scale to measure this weight correctly? Well, the steps are as follows. First, we put an approved weight on the scale. Afterwards, we have a legal range. If the scale is not measuring the weight on it within that legal range, we understand that the scale needs to be readjusted. So these are the set of approved weight types we have. You know, we have different classes. We have the E class, we have the M class, we have the F class, so on and so forth. And These are more or less the scale weights that we use to calibrate the scale. And of course, the types, as you can see, I think if I'm not wrong, it's a 1 ton weight. Yeah, it's probably a 1 ton weight. And depending on the type of scale we have, we use different types of weights to calibrate the scale. So what are the steps? They're as follows. So initially, a process that we call zero adjustment is applied to the scale. We can think this as teaching the scale what zero means. It is done when there is no weight on the scale whatsoever. The scale learns that there is no weight on it in the current state. And then we perform what we call span adjustment, where we teach the scale the maximum capacity that we will be using the scale for. An approved weight is placed on the scale, and the scale learns how many kilograms it currently weighs. This is something legal. I'm legally speaking here. It is recommended that we choose the weight to be selected that we are going to be using to calibrate that equipment. In the worst case scenario, this is the absolute minimum weight that we can choose for the scale to be measuring for calibration purposes, 10%. And by the way, it is not always correct to choose 10% because, when the maximum capacity increases, we have a readability issue. So 10% might not be readable for the scale that we are using, but the minimum amount of weight that we will be using should be around 10%. However, the usual go-to with scale calibration, the amount of weight, is usually 40 to 50%. And after we apply span adjustment, the weight values all the way from 0 to the maximum capacity, they are calculated by basically a simple math equation, simple math operation that is done by the scale. This is very technical, but the pressure that is created on the platform, the scale divides and multiplies it by certain numbers, and then it knows how many, the amount of numbers that it should weight. The operator, he only needs to do zero adjustment and then offset adjustment. That's all he needs to do. So now, since we extensively explained what calibration is and the stages of calibration, I think it is necessary to explain what is the problem with manual calibration in the first place so that we needed to come up with electronic calibration. Well, when you say scale to normal individuals, people that are not aware of the industrial and the microanalytic balance side, they usually think of scales that they see in the supermarkets or they have in their homes, in their bathrooms to measure the weights of themselves. And these scales are, their capacities are 30 kilograms, 60 kilograms, maybe 100, or extremes are also, possible, 200 kilograms. And, when that's the case, finding 10% of that much weight or 40 to 50% of that much weight is not that hard. Because if you have a scale that measures 30 kilograms max, the amount of weight you need is going to be 3 kilograms. It's pretty straightforward. You have a scale, you have weights, and you have a procedure that you need to follow. It's straightforward. In the worst case scenario, it's going to take a couple of minutes. However, consider bigger scales, a tank scale, or a truck scale, or a factory integrated weighing system. All the things I just said, finding a weight for this types of scales, it is easy, it is straightforward, what might be the problem, all of things that I said that sound very easy, they suddenly become very big problems, especially in the field. Because scale is at the end of the day a measuring equipment, and we might have some special things to do with those scales. So we might not know what the person is using this scale for and the maximum capacity that the person is going to be working with. Therefore, as I said, all of the things that you might find very easy, they suddenly become extremely problematic. And since we are an industrial weighing equipment producer, the feedback that we got from the field, the most popular problems, you might say, are as follows. One of the biggest problems is the fact that you need weights to perform manual calibration. As I said, for scales that weighed 100, 150, 200 kilograms, finding that much weight to calibrate the scale is not that hard. But however, as you can also see here, imagine a tank scale that might weigh 50 tons, 100 tons, 500 tons even. 10%, which I believe is not recommended, but finding 10% of that much weight is going to be 5 tons. For 100 kilos, it's going to be 10 tons. For 500 kilos, it's going to be 50 tons. This is a lot of weight. The cost is way too much. You might even end up paying just as much you paid for the scale to calibrate the scale, which is unsustainable, in the long term. Let's assume you found the weights, which I believe is the most difficult part, but let's assume you found them. It is not just about finding the weights. It is also about loading and unloading all this weight to the scale you have without damaging your system, without damaging your factory, without causing too much time, labor, and resources. That is also a problem. Because we have a tank scale in this example as well. Let's assume that you have a tank scale just like this. You are going to depend on machinery, hard labor, and weights to load and unload that much weight to your, so to say, scale. All of those people, all of those machines, and also not just about people and machines, you're also going to require resources to keep those machinery that you rely on to carry that much weight sustainable. You are going to need resources. Well, you have a forklift here in the example, and you're also going to need to be taking care of that forklift, which also costs you extra resources. All of these things, they cause you productivity, they cause you time, they cause you labor, they cause all of the things that you could have used for your own operations. It is hard. It is not profitable, and it's basically a reason for your productivity to stop. Right. Okay. Also, the logistics. Logistics of that much weight is also a problem. People used to transport tons of iron just to calibrate a scale. Well, since this is extremely costly, people, they looked for alternative solutions just to alleviate this difficulty a little bit. For example, as you can also see in the slide, people used to carry, water with tankers to their field to not rely on iron that much. However, more precisely, this might be an easier way for you to choose to calibrate your weighing equipment, it has its own problems. I mean, finding that much water, that's a problem. I mean, it's not a bottle or 2 bottles, it's a tanker worth of water. Finding that much water, finding a tanker in the first place, getting that much water into the tanker, transporting that much water into the field, and also pouring that much water into your tank and doing the reverse of all of these processes, they're also problematic. They also cost time, labor, and money, and of course, extra expenses. Another alternative solution that might be, preferred is also you might use products that you have in your warehouse that you already know the weights of. This is effective. You have a weight, you have a certain product that weighs a certain amount ready in your factory. All you need to do is perform calibration. It might be easy. However, this doesn't change the fact that you still need weights. to perform manual calibration. You might not have this product in your factory. Who knows? It is going to be problematic, and this also requires a lot of labor and time. Like, you have weights, a very big part of the problem is solved, yeah. However, you still need people or even machinery to carry this much weight, and you're going to lose time trying to calibrate the weighing equipment still. Because as I said, this is still a manual way of calibrating a weighing equipment. So now, we have discussed the most common problems that people face trying to manually calibrate their weighing equipment. And these are as follows, like finding that much weight, loading and unloading that much weight, logistics, the amount of money, labor, and time that is essential to do so. So how do we solve all these problems so that it requires no labor, time, or resources at all? Well, we have a solution, and we call that solution electronic calibration. At this point, from the feedback that we got from the field, we have chose to integrate a technology called electronic calibration. It requires no logistics, it requires no labor, and it's, in the worst case scenario, would take 5 minutes, and it requires no involvement of any type of weight of any range whatsoever, because this is fully electronic. Electronic calibration, it's simply done by writing the certificate values that you have on your load cell, which are, if I'm not wrong, the capacity, the related output, the division value of your scale. And by entering those from your device, that's basically it. That's all you got to do. Like, the rest is done by the device itself. It does a very simple mathematical equation, a very simple mathematical operation to understand the weight values that are in between. Just like, when I talked about manual calibration, the difference is that this relies more on the electrical, how do you say that? Anyway, the electricity part of the equation, other than relying on physical weights. And you can also see how easy it is from one of the videos that we have. Bu çok önemli değil ama. I'm going to try something. Hopefully the music will reach you. Okay. Hopefully that was straightforward. Well, Okay. After electronic calibration, after electronic calibration is done, there might be minor errors. Like these minor errors can easily be repaired through another feature that our devices have called the span adjustment. The video to explain how span adjustment is applied is as follows. Yeah, pretty cool. So now, since we explained what normal calibration is, the problems with normal calibration and electronic calibration briefly, now we are going to be talking about the devices that we have in our portfolio that have this technology integrated in them and in what way it provides ease in the field. So we are starting with process-related equipment. So first we start with our analog transmitters. So our analog transmitters are designed for easy integration with PC and PLC related weighing processes. With electronic calibration, these devices work similar with what you saw in the video, but instead of displaying the weight, it sets the output signal that it sends to whatever process that the guy or the person in the field has. So you can say it works just like a scale. However, instead of displaying the weight, the process changes. Now we have the digital transmitters. So digital transmitters work with a similar logic, but instead of giving an analog signal, it gives a digital signal to the process-related equipment that is transferring the signal to. And with having this digital technology, signal technology integrated to a device, you basically have advantages, like you prevent fluctuations with the signal losses, waves that occur with analog transmitters. So as I said, it works just like a analog transmitter. However, the signal is different and that has some advantages. And electronic calibration basically works similarly. Yes, BX1X series process indicators. Yeah, these are some cute indicators. I like them a lot. Yeah, these mini indicators are designed for extremely fast filling, packing, and totalizing based process applications. We have already seen how it is performed on a video when you have an indicator. And these devices have factory integration protocols built in them. And their ability to record, totalize, integrate data make it very, very important for us to be seeing whatever value it measures as precisely and as accurately as possible, because these are really fast. Like I told them these are cute. I told you guys like these are cute. However, like don't let that fool you. They are extremely fast. And when you work with this much speed, it makes it extra important for you to measure whatever you're measuring as accurately as possible. We also, just like the BX1X series, we also have process. Yeah, this is a bit mistake. Anyway, BX2X series weighing indicators. Don't let this writing here full U. These are weighing indicators. Anyway, these indicators are equipped with basic and complex weighing indications and also some very basic process-related functions. Like it is not like the BX1X series or the BX3X series that you will be seeing, not as complex as that. However, they are able to do some very basic process-related actions as well. And BX2X series indicators, are the advanced series ones, and the one that we are going to be seeing, BX3X series, are the advanced process series indicators, which we have right now. So these are different from the BX1X series. These indicators are responsible with complex, process weighing functions. And you can think this as a PLC system, integrated inside an indicator. In other words, with process-related functions that you would normally do with a normal indicator, purchasing these indicators right here, purchasing these, you will be excluding yourself from an expense that might occur if you would have purchased an additional PLC unit. These are like process-related indicators with PLC functions built in them. So yeah, advanced terminals. Yeah, so these are Windows CE-based weighing terminals that are designed to track, record, analyze weighing data, and they work just like a computer. And you can also customize the software that you have that fits your own application. And these devices, since they are similar to a computer, they would work just fine. And yeah, so they also have the weighing cards in them, so you do not need an additional indicator to, record your measurements. Like legally speaking, you can use them. And yeah, as I said, since they are just like a computer, like not exactly like a computer, but just like a computer, you can also customize your own software with them. And we have our industrial PCs. Yep. So these are complex industrial PCs that are designed to track production and weighing processes on a fully computerized environment. So what is different from the previous devices that we saw, these are fully computerized. Like using this is almost indifferent to using a computer. And with customer and producer oriented softwares that we have, and also you might have, it makes things very easy for us since, as I said before, it is a completely PC-based environment with Windows operation system. It's like a PC, but with complex weighing functions, basically. All right, so just like this webinar, there will be many other webinars where we will be talking about innovations and renovations in the weighing industry. In order to be informed about these webinars or anything new about BAYKON, you can create a subscription from our website. You can see the website here. There's also a QR code version. This webinar is going to be available on our social media accounts. You can also, I think YouTube specifically, and there will be like bridges to take us to the YouTube video.